Hello again, everyone. Mr. Cruze here with another review for you. This time, Trigonometry, sections 2.5 and 2.6. Just doing a little bit of trig story problems and a little bit of given a point, can you find the 6 trig values for an angle that terminates at that point? So, let's begin. Number 1, a regular pentagon, 5 equal sides, is circumscribed about a circle with an apothem of 10.8 centimeters. Okay? So, we have a circle around. The apothem, this is the big thing you'll need to remember, so it might be a good thing to have on your note card. The apothem is from the center of the pentagon down perpendicular, so I could probably draw a little bit of a better picture than that, perpendicular to the side of the pentagon, okay? And the apothem's 10.8. Not the clearest to read there, 10.8. They want to know what's the radius of the circle. So we want to know how far is this, the radius. Alright? Well, really, all I need is that triangle, right? I just need this triangle with 10.8 here, and I need another radius. Well, obviously, I need one more piece of information before I can actually solve this, right? And usually with trig stuff, we need an angle somewhere in here. So I need one of these angles. Well, here's the cool thing. If I back up just a little bit, just normally to the pentagon, I can break it up into 5 of these triangles from the center point, right? And there's 360 degrees around the center. So that means each of those 5 triangles shares 72 degrees, okay? There at the center. So this is 72, this is 72, this is 72. All these are 72 around the center, okay? But the thing is, I don't really want 72. I'm taking half of it by splitting it with the apothem. So what's half of 72? 36. It means my angle here is 36 degrees. And now we have the trig part set up. So we figure out what sides we have. We have the adjacent side to the 36, and our radius is our hypotenuse, of course. So that would be the cosine. So cosine of 36 degrees, this is part A, by the way. Cosine of 36 degrees equals adjacent over hypotenuse. Mr. Cruze's pro tip, remember if the unknown variable is on the bottom of your fraction, you can switch. It's a property of proportions, right? You can just switch it. So you take 10.8 divided by the cosine of 36, and you get the radius to be 13.35 centimeters. Just make sure you type that in carefully. So your radius is 13.35 centimeters. Alright, then they say, what's the length of one side of the polygon? So basically, how long is this, right? But remember, that's also half of the side, so we'll have to double our answer. So let's just call that x. And again, you can use the same thing, only I wouldn't recommend using the hypotenuse since you rounded that to get that previously. So this is the opposite. So you're going to use something that has opposite and adjacent. That would be tangent. So tangent of 36 equals opposite over adjacent. This time you don't have to do the switch. X will just be 10.8 times the tangent of 36, and that gives you the length here, at least half of the length, of 7.85. Okay, but again, we have to double that because that's only half of the side length. So if you double it, the side ends up being, I'm going to erase my triangle here, 7.85 times 2 ends up being 15.70 centimeters. So there's your 2 answers. Alright, number 2, a 30-meter line is used to tether a helium-filled balloon. Because of a breeze, the line makes an angle of 75 degrees with the ground. So we have some sort of triangle here. The balloon's up here, and it makes a 75-degree angle with the ground. They want to know what's the height of the balloon. So I'm going to use a different variable than h. Let's just call it x. 30-meter line. The line itself is 30 meters. That's what's tethering the balloon, so that would be this one. Would make sense to go on the bottom, okay? And they want to know what's the height of the balloon. So this x is the opposite of our 75-degree angle. 30 is our hypotenuse. So you're going to use the sine of 75. That equals x over 30. Again, variables on top, so use cross multiply. So x will be 30 times the sine of 75. It says round to the hundredths place, so that'll be 28.98 meters. Again, these are all just typing in your calculator. If you need help with that, please let me know. An airplane flies at an altitude of 5 miles toward a point directly over Mr. Kaler. Mr. Kaler has a horizontal distance of 10 miles to the airplane. So there's some airplane flying, right? Mr. Kaler's over here. Artist's approximation of Mr. Kaler. He's a horizontal distance of 10 miles to the airplane. Okay, so the airplane's flying up here. There's its wings, right? Flying at an altitude of 5 miles, that's the height. We want to know what's the angle of elevation. What's theta down here? What angle would Mr. Kaler have to look up at to see the plane flying towards him? Alright. This one's missing an angle, so something special will happen. We have our opposite, and we have our adjacent, so that'll be tangent. So the tangent of our angle is 5 over 10. You can reduce that if you want. It doesn't really matter. But here's the very important thing that might be another thing to have on your note card. When you're finding the angle, that's when you have to use the inverse, also known as the arc, trig functions. You have to use the inverse trig functions because you have to break it out of the theta. No dividing by tan, can't do that. But you can take the second tangent, inverse tangent. And if you do, you end up getting 26.57 degrees. From a 60-foot observation tower on the coast, so I'm going to draw a tower, 60 feet. Coast Guard Officer Bruns sights a boat in difficulty. So out here somewhere, he looks out, and he sees a boat in difficulty. Yes, it looks awful. That's why it's in difficulty. The angle of depression to the boat is 3 degrees. This is where I think people struggle. Angle of depression. All right. That means that's the angle that he's looking down. So normally, he's going to start out looking towards the horizon. He's looking down at a 3-degree angle. Okay. There's a couple ways you can handle this. But the easiest way is, remember from geometry, that there are a couple angles here that are congruent. This angle and this angle. That makes this 3 degrees down here. The person in the boat is looking up at Coast Guard Officer Bruns at the same angle he's looking down at them. That's how their eyes meet. Okay, 3 degrees there. So really, you no longer need this part. The big no-no is don't put 3 degrees here. That is wrong. Okay, so don't do that. Anyway, we want to know how far is the boat from the base of the tower. So you put an X there. Alright, so 60 is our opposite side. X is our adjacent. So again, that's tangent. So tangent of 3 degrees equals 60 over X. Once again, X is on the bottom, so pull the old switcheroo. 60 over the tangent of 3 degrees. Type that in your fancy calculator, and you get 1144.87 feet, which should make sense. If you get an answer that's like, I don't know, 5 feet, then that's way, way wrong. I would hope that the boat's not that close. Alright, these are the last ones. Given the point of the terminal side of the angle in standard position, find the 6 trig ratios. Be sure to simplify. So, we have an XY ordered pair, 20, negative 21. So, we're going to plot that. If the X is positive and the Y is negative, that means it's in quadrant 4. It's down here. X is 20 and our Y is negative 21. Okay. Here's your angle. We need to figure out the 6 trig functions. Well, to do so, we need our hypotenuse. It's a right triangle, so you'll have to use Pythagorean theorem. You have to do 20 squared plus negative 21 squared equals your radius squared, or your hypotenuse squared, right? Good news is that's, what, 400, 441, so that's 841. And the square root of 841 is 29. Hey, that's nice. No radicals in this one. So your sign will be opposite. Might as well label these opposite, adjacent, and hypotenuse. Opposite over hypotenuse, so that'll be negative 21 over 29. Cosine will be adjacent over hypotenuse, so that's 20 over 29. And tangent will be opposite over adjacent, so that's negative 21 over 20. To get the others, you literally just flip those. So flip sine to get cosecant, that's negative 29 over 21. Secant is 29 over 20. And cotangent's negative 20 over 21. Don't forget, this is quadrant 4, so cosine and secant should be the positive ones, right? Remember, all students take calculus for your little way to remember that. All right, negative 1520. This time the X is negative and the Y is positive. That means we're in quadrant 2. So X is negative, negative 15. Y is positive 20. Once again, you're missing the hypotenuse, so you have to find it using Pythagorean theorem. Negative 15 squared plus 20 squared equals r squared. Negative 15 squared is 225. 20 squared is 400. So you end up with 625 equals r squared, so r is 25. That's nice. R is 25. Once again, no radicals. If there are radicals, make sure you rationalize your denominators. The sign will end up being, here's your angle, so you can label opposite, adjacent, hypotenuse. Opposite over hypotenuse will be 20 over 25. Makes sense, sign should be positive in quadrant 2. Cosine will be negative 15 over 25. Tangent will be 20 over negative 15. Now the only thing is, we should probably reduce those because it does say simplify. So 20 over 25 is 4/5. Negative 15 over 25 is negative 3/5. And this one will be negative 4/3. Flip those to get the others. Cosecant will be 5 over 4. Secant will be negative 5 over 3. And cotangent will be negative 3 over 4. Alright? There it was. Quick rundown. Your quiz won't be much different than this tomorrow. Even if we have a 2-hour delay, the quiz is pretty short, so it shouldn't take you very long. The big thing that I would focus on, guys, is make sure that you know how to set up these word problems. If you can set them up, I have every confidence in the world that you can set up the trig part. It's just, can you draw a picture of what's going on? Always look for that right triangle somewhere in the problem, okay? And they should give you 2 pieces of information to solve this stuff, all right? If you need anything from me, as always, tweet me, leave a comment in the video, email me, come in early in the morning, or somehow get a hold of me, all right? Good luck studying, and I will see you tomorrow.